Okay, students, so this is wrapping up our review. This is the last 6 problems about applying your exponentials and logs to solve for y in this case. So let's just look and see where is y in your problem. Okay, you notice here that y is in your exponents. Y is in your exponent. So the one way that we can take the exponent out is if we apply the property of the natural log, or of the log. Okay, so if we have the log of m to some n power, okay, so if we're taking the logarithm, that means we can take the power and bring it to the front. Okay, so notice right now we don't have a log, so we want to take the log of both sides. Okay, now not just any log, we want to make sure that we're able to cancel out our base of a 2. So we're going to take the log base 2, right? The base of your log needs to match up with the base of your exponents. So because we have a 2 as our exponent base, we're going to have a log base 2. Okay? Because this, when the bases are the same, the answer is your exponent, right? It comes to the front times 1, so in other words, we don't have to worry about multiplying it by anything. So that's how you get the y out of an exponent, or x out of an exponent, is by taking its log and applying that property to it. So then our last step of adding 3, we don't really add 3 to anything. We just basically write it down after the 6, right? Plus 3. Because according to PEMDAS, we would first have to evaluate this log base 2 of 6 and then add 3 to it. So it's not 6 plus 3 equals 9, but the log base 2 of 6, whatever that is as a decimal, plus 3. Okay, so you can put it after, or to remind yourself that you don't actually add it, you could put it in front of the word log. That way you know not to actually add it to anything. Okay, leave it like that. Okay, 37. Once again, we have log, we have 5 to the 2y. Your variable that we're trying to solve for is in the exponent, so we're going to take the log of both sides. Okay, now not log 10, but we're going to take the log where your bases match up. So we're going to take the log base 5 of both sides. Okay, because when we take the log base 5, the 5 and the log and the 5, all that stuff cancels out, and your answer is just the 2x, or 2y. Sorry, 2y. Okay, so then dividing everything by 2 gives a 1/2 times log base 5 of x plus 1. Okay, if you don't like that, we can write it as log base 5 of x plus 1, all divided by 2. Okay, but there's some nifty things we could do, but we're not gonna, by taking the 1/2, because now you can make it into a power, right? And then you can change that into a square root, so you can simplify it a little bit, but that's fine for us for right now. Okay, 38. The same thing applies, right? Your variable is in your exponent, so we're going to take the log of both sides. In this case, the log of e, which is natural log. So whenever we have e as the base, we're taking the natural log, which is log base e. Natural log and e cancel each other out. So y over 2 equals that, and I solve by multiplying both sides by 2. So the answer will be 2 times the natural log of x minus 3 equals y, right? Since we want to solve it for y, let's go ahead and do all of it. So here's your final answer. So whenever we have an exponent, your variable's in an exponent, the strategy is to take the log of both sides. But what is key is that the log of your base needs to match up with the base of your exponential. Okay, those two things have to match up when you want, if you want things to cancel, or rather undo each other. So are these ones, here we have the y value, the y values in the argument, right? That's the argument of your log. So how do you get it out of the argument? Well, you change your logarithm into an exponential. So we're going to write this as an exponential. And it goes like this. The base of your log becomes the base of your exponent. The answer of your log becomes the power of your exponent, and then the argument of your log becomes the answer. So that's how we rearrange the furniture with logarithms. Now 2 to the 4th, that's 2 times 2 times 2 times 2, that's 16. Right? So this is a number. We're able to evaluate this number. 2 to the 4th is a number. So we evaluate that, and then we divide everything by 2, and 8 divided by 2, or sorry, 16 divided by 2 is 8. Okay, pretty fantastic answer. So we're writing our log as an exponent in order to get your y value out of the argument. So our log has a base of 5, so your exponent has a base of 5. Your log has an answer of x plus 2, so your exponent has an exponent. Or your base has an exponent of x plus 2. Okay, and technically you don't need that in parentheses. And then we have y minus 3 as the answer. So when we add 3 to both sides, right, we can put it in a couple of places. One, the traditional place, is just after your exponent. Right, that's perfectly fine if you do that. Okay, it's also okay if you put the 3 in front of your 5. Okay, like that. But no, it does not actually combine with anything. Okay, that's not the same as 8 to the x plus 2, and that is not 5 to the x plus 5. Okay, it is this exponential equation, 5 to the x plus 2 plus 3. So don't combine things that aren't actually combinable. And lastly, natural log, we need to know, right, remember forever that natural log is log base e. So this becomes e as the base to the 4th power equals 2y plus 1. So the base of your log becomes the base of your exponent, and the y is no longer in your argument, and we can solve this by minusing 1 from both sides and then dividing everything by 2. So we can have e to the 4th minus 1 all divided by 2. Or if you're so inclined, we can always just write it as 1/2. So dividing by 2 and multiplying by 1/2 is the same thing. Okay, so either one of those two ways is acceptable in order to write your answer. Okay, so when you're solving for y, if y is in the exponent, you take the log of both sides. And if y is in the argument of your log, then you exponentiate in order to solve for y. Do good on your test. Okay, bye.